Welcome again, Wildcats. All right, so today we're looking at Friday, February 3rd, and we're going to solve, graph, and check all functions. Okay, so if you would, pause the video and update your table of contents. All right, now that your table of contents are updated, let's take a look at our examples. Now, you'll notice that today there are no notes. We're just going to have examples, and that example page is going to be on page 53 in your journal. Okay? All right, so let's take a look. It says solve each equation algebraically and graphically. Now, in these directions it says solve algebraically and check, but let's change that. And this says solve graphically. So really what we're doing is solving algebraically and we're graphically checking. Okay. All right. So to solve example number 1, you need to move everything to the left side. Okay. So we're going to subtract 2x and subtract 1 from both sides. When you do that, you get 2x squared minus 2x. Now, when you subtract 2x, that's here, but when you subtract 1 from 1, you get 0, so you don't need to put the plus 0, and that equals 0 because you subtracted them. Okay? So now we see that we can factor these terms because there's a greatest common factor of 2x. So use 2x times x minus 1 equal to 0. Okay? So you're going to set each of these equal to 0. So here you divide 2 by both sides, so x equals 0. Here you add 1 to both sides, so x equals 1. Now you'll notice that we solved a quadratic, and a quadratic has the highest exponent power of 2, so that tells us it's going to be 2 solutions, which is what we got. Okay, now let's graph. What we're going to do is we're going to graph the left side, and we're going to graph the right side. Okay. Now, I'm going to be using something new. These are called friction pins. I don't know if you've seen these, but they're pins that you can erase. It's craziness. Okay, so I don't know how it works, so give me about maybe 8 seconds to figure out how to work. Oh, there he goes. All right, so I'm going to graph the left side in blue, and I'm going to graph the right side in pink. Okay, and so what you're doing is when you solve, okay, basically what you're trying to do is find out when the left side and the right side where they intersect. Okay, so all right, so to graph the left side, we know that we start by transformation, we go up 1, okay? And then from there, we're going to make a table, a directions table. Okay, so now we know in a quadratic, the directions are always -2 for left 2, up 4, left 1, up 1, okay, right 1, up 1, and right 2, 4. But in this case, we have to multiply all the y's by 2. So that equals 8 to 2, 8. Okay, so let's graph that. Okay, so from here we go left 2, up 1, 2, 3, 4, 5, 6, 7, 8. We go left 1, up 1, 2. We go right 1, up 2, right 2, up 8. Okay. Now we're going to graph the right side, and again we're going to graph it in pink. Okay. So here it's a linear function. So we go up to the y-intercept, which is 1, and then from there we use slope, which is in this case 2 over 1. So we go up 2 to the right 1, up 2 to the right 1, up 2 to the right 1, up 2 to the right 1. Then you go the other direction, down 2 to the left 1, 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 down 2 to the left 1. All right, so you'll see that they intersect. And when you're looking to check your solution, you're looking for the point of the x value of the point of intersection. So they intersect here at 0, 1, but we're just looking at x equals 0. And here they intersect at 1, 3, but we're just looking at when x equals 1. So this verifies that the solutions of x equals 0 and 1 are correct. All right, so if we would pause the video and finish up example 1. All right, so now that example 1's finished up, let's look at example 2. All right, so example 2, we see that everything's moved to the left. Okay, so we see it's a quadratic. Now, when solving a quadratic, you have three options. Option 1, factor. Option 2, complete the square. Option 3, quadratic formula. We always go for factoring first because factoring is the fastest. So we're going to draw our box. So first term, last term, and we want the middle terms to combine to be negative 5x. Okay, so we know that 2x times 1x make 2x squared. Now we need to find the combination, all the combinations to make 3. So we know that negative 1 times negative 3 and negative 3 times negative 1 are your only combinations. So let's see which one, if one or none of them work. So let's try negative 1 here and negative 3. So 2x times negative 1 is negative 2x. Negative 3 times 1 is negative 3x. They combine to be negative 5x. This factors, so we have 1x minus 1 times 2x minus 3 equal to 0. We're going to set each of these equal to 0, so x minus 1 equal to 0, and 2x minus 3 equal to 0. We add 1 to both sides, x equals 1. There's one solution. Remember, we know we're solving a quadratic, so we know it's going to have two solutions. Okay? Here we add 3, divide by 2, so x equals 3 divided by 2, which we know is 1.5. All right, now, when graphing, we can actually use these 2 points because since it was set equal to 0, we're actually finding the x-intercepts. Okay? So again, I'm going to graph the left in blue, and I'm going to graph the right in pink. All right, so we already have 2 points of this graph. We have x equals 1 and x equals 1.5 is the x-intercept, so we know that 1, 0 and 1.5, 0 are 2 points. Now we need to find the vertex. So to find the vertex, we know that x equals negative b divided by 2a, which we know that negative 5 divided by 2 times 2 equals positive 5 over 4. So we know that that reduces to be x equals 1.25. Now we need the y value of the vertex, so we're going to plug in that value into y equals 2x squared minus 5x plus 3. So that's 2 times 1.25 squared minus 5 times 1.25 plus 3. Which when you plug that in the calculator, you'll get y equals negative 0.125. So let's graph the vertex. So we go over about 1.25 down. Such a small point, so you're just going to approximate it, but you know it's there. Okay. So we also know that we can graph the y-intercept, which when it's a y-intercept, the x values are 0, so we cover those up, and the y-intercept is 0, 3. So 0, 1, 2, 3. We have enough points to graph. All right, so now we graph the right side, which we know is y equals 0. So we see that the left side and the right side intersect at x equals 0. Or no, I'm sorry. Whoa, what am I saying? X equals 1 and x equals 1.5. So we've checked, and those are valid solutions. All right, so pause the video, finish up example 2. Now, one thing I should have said is what I'd like you to do is follow along, and like if you kind of follow along example 1, you had trouble with it, put a little note and remind me to work example 1. Same with example 2 or 3 or 4. If you kind of get frustrated, you kind of like, oh, I'm struggling with it. Basically, you can stop, follow along, still watch, but then look at your work, and then you can ask me, and I'll go back over it. Okay. I plan to go over all the examples, but I really want to have the discussion of which examples do you really want to go over? Do we need to go over all of them, or is it just example 2? Is it just example 4? Is it examples 1, 2, and 3? So just be ready to let me know in more detail which specific examples we need to go back over. Okay. All right. So let's look at example 3. Now, example 3 has a mistake. It should actually say the square root of x minus 1 equals square root of 1 minus x. So mark that out. All right. Now, to solve that, whoa, what was that? Oh, that's those bells again. Silly bells. All right. So we know we have square roots on both sides, so we're actually going to square both sides. So they both become to the power of 1. So you get x minus 1 equals 1 minus x. So we're going to add x to both sides. I'm going to put 1s in front of x's. So 1x plus 1x is 2x. Minus 1 equals 1. That cancels, becomes 0. So then you add 1 to both sides, you get 2. And then divide 2 by both sides, so x equals 1. All right. So now we know x equals 1 is the solution. We need now to graph and check. So again, I'm going to graph the left side in blue. So I'm going to rewrite it. I'm going to graph the left side in blue. So square root of x minus 1. I'm going to graph the right side in pink. Now, I'm looking at this, it's kind of confusing to see it that way, so I'm going to actually rewrite. The left side's fine, there's nothing, but I'm going to rewrite the left side's fine, the right side I'm going to rewrite as negative x plus 1. Okay? Alright, so to graph the left side, we know we graph by transformation, so we know that the minus 1, we go to the right 1. Okay? And then we know because it's square root, we go right 1 up 1. Right 4, 1, 2, 3, 4 up 2. Then we go up right 1, 2, 3, 4, 5, 6, 7, 8, 9, up 3. All right, so that's that one graphed. Now we're going to graph, and this one's really throwing me off. So what I'm going to do is actually I'm going to grab a calculator and graph them to see what it looks like, and then I'm going to check that with conclusions. So let's graph. And actually, you know what? I think instead of doing that, I want you to try to finish example 3, and then I want you to walk me through example 3 because I honestly don't know how to finish example 3. So I need y'all to help me finish example 3 in class. Okay? It's confusing me. I don't understand it. So work through the rest of it, and then see if you can explain to me in class. All right. So let's look at example 4. All right. So to solve, we're going to subtract 6 from both sides. So you get the cube root of x minus 1 equals 1. We're going to cube both sides. That becomes the power of 1. You get x minus 1 equals 1. Add 1 to both sides. X equals 2. All right, so we've got our solution. Now let's graph and check. And again, I'm going to graph the left side in blue. Okay, and I'm going to graph the right side in pink. Okay, so now to graph the left side, we go by transformation, so we know we're going to the right one, up 1, 2, 3, 4, 5, 6. And then because it's a cube root, we know we go left 1, 2, 3, 4, 5, 6, 7, 8, down 2. Then we go left 1, down 1. We go to the right one, up 1. To the right 1, 2, 3, 4, 5, 6, 7, 8, up 2. Okay, now the right side's easy. It's just y equals 7. So we go up. Whoa, what was that? Oh, just a bell again. Those silly bells. So 1, 2, 3, 4, 5, 6, 7. All right. So we see that they do intersect, and they intersect at the point 2, 1, 2, 3, 4, 5, 6, 7. So because the x value of the intersection point is x equals 2, that verifies that the solution is x equals 2. All right, so take some time to reflect over these examples and think about which ones you understood, which ones you didn't. Like for me, example 3, I just didn't understand. That's my reflection, and we need to talk about it in class. And then think about, do you want me to go over all the examples in class? Whoa! Sorry, those bells again. And then think about which examples you want to discuss in class and which ones you don't, and things like that. And just let's start class with that discussion on Friday. So with that, have a rockerific Wildcat day.